In today's video, I will provide a little tutorial for you on solving common competition problems like this one. I say common because they make their appearance quite often. As you can see, our job is to find the value of this sum which has 2024 terms. If you try to solve this problem by brute force approach, i.e. by calculating the first fraction, then the second fraction, the third one, and so on until you reach the last one, and then add all those results together, it will take you a considerable amount of time of your life, and you are probably going to give up after first 2 or 3 calculations. In order to solve this problem, we have to first notice a pattern which appears. In the numerator of every fraction you have number 1, and in the denominator of every fraction you have the product of two numbers. So for the first fraction those numbers are 1 and 2. And for every fraction after the first one, you are going to take the numbers from the previous term and raise both of them by 1, and that will give you the denominator of a current fraction. So for the 2 multiplied by 3, you are going to take 1, raise it by 1, 1 plus 1 is 2, and 2 plus 1 is 3. So that will give you the denominator of the second fraction. So let's pick one of these fractions and analyze it. I decided to pick the fraction of a 1 divided by 2 multiplied by 3. It doesn't matter which one you pick, any one will suffice. As you can see, this number 1 from this fraction can be written as 3 minus 2 because we already have 2 and 3 figurating in the denominator of that fraction. Now you can transform this fraction into 3 divided by 2 multiplied by 3 minus, and another fraction is 2 divided by 2 multiplied by 3. And at this point you see then you can cancel out 3 and 3 and 2 and 2, and you are left with 1/2 from the first fraction minus 1/3 from the second fraction. We can now ask a question, is this idea going to work for all the terms which we have in our sum? As you can see, the general term of our sum is 1 divided by n multiplied by n plus 1, where this number n goes from 1 to 2024. So if you plug the value of n to be equal to 1 into this 1 divided by n multiplied by n plus 1, you get the first fraction, 1 divided by 1 multiplied by 2. If you plug in the value of 2 for n, you get 1 divided by 2 multiplied by 3, which is the second fraction of our sum. And so on. If you decide to plug in the value of 2024 into the value of n, you get 1 divided by 2024 multiplied by 2025. And that is the last fraction in our sum. Let's use our idea on this fraction, 1 divided by n multiplied by n plus 1. First, we are going to write number 1 as n plus 1 minus n, as n and n plus 1 are the numbers figurating in the denominator of our fraction. N multiplied by n plus 1, and then we get that this is n plus 1 minus n divided by n multiplied by n plus 1. And again we are going to make two fractions. The first one is going to be n plus 1 divided by n multiplied by n plus 1 minus, and the second fraction is n divided by n multiplied by n plus 1. And again you see that n plus 1 can cancel out with n plus 1, which leaves us with just 1 over n from the first fraction, minus, and n can cancel out, and we are left with 1 over n plus 1 from the second fraction. So this is the proof that our idea works for every term with a fraction in our sum. So let's apply this to all fractions of our sum. We get that our sum is equal to 1 over 1 minus 1 over 2. And then the second fraction is 1 over 2 multiplied by 3. When we apply this, we get 1/2 minus 1/3. plus for the third fraction, you see that we have a 1 over 3 multiplied by 4, and that is 1 over 3 minus 1 over 4. And so on. The last term of our sum is the fraction of 1 over 2024 multiplied by 2025. And when we apply again this, we get 1 over 2024 minus 1 over 2025. As you can see now, this negative 1/2 and positive 1/2 are going to give us 0 as their sum. Again, a negative 1/3 and positive 1/3 are going to give us 0. Negative 1 over 4 and positive of 1 over 4 are going to give us 0. And we have from the previous fraction, the previous term of this sum, negative 1 over 2024. And with this positive 1 over 2024, it is going to give us 0. So everything is going to fall into the 0 except the first term of 1 and the last term of negative 1 over 2025. So we have 1 minus 1 over 2025. And this is equal to 2025 minus 1 divided by 2025, which is finally going to give us a result of 2024 over 2025. The reason why this problem is so popular on competitions is because of its general form. It is 1 over 1 multiplied by 2 divided by 1, 2 multiplied by 3 plus 1 divided by 3 multiplied by 4, and so on, 1 divided by n minus 1 multiplied by n. And here, as you can see, instead of the last term being 1 over 2024 multiplied by 2025, we have 1 over n minus 1 multiplied by n. Now we are going to use the same idea from before. So we have a 1 over 1 minus 1 over 2 and plus 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4 and so on. 1 over n minus 1 minus 1 over n. And again, everything is going to fall into 0 except this first term, which is 1, and the last term, which is minus 1 over n. So this will give us n minus 1 over n. And as you can see, you can just plug in the value for n to be a current year when a competition is held. And by doing that, you have a new problem for every year that you hold a competition. It's a lazy way to generate infinitely many problems. So thank you for watching. I hope that you have enjoyed this video, and if that is the case, please support my work by subscribing to the channel. If you want to see more of my work, I would recommend that you watch this video next.